Alright, good day everybody, and today we're continuing with the types of numbers. This will be our part 2. In our last video we did the part 1 where we basically discussed the definition, the concepts of all the types of numbers that we need to know at this level and for our examination purposes. And today we're going to go on to just doing varied activities in which of course apply the concepts that we know from the types of numbers to make our answers or our life a lot easier moving on. So what is our objective for today? For today, we are hoping to solve problems involving understanding the types of numbers. So if we do not know the types of numbers, the question that we are about to approach here could pose difficulty, especially maybe when we meet it in a multiple choice or in a short answer question that requires us to know the specific answer. I mean, if not, I guess we could always guess, but why guess when you could know for certain? So if you haven't looked at the part 1 to this video, you can go ahead and look at it. It will make your life a lot easier for this one. Or if you are as endearing as me, you can just go ahead, take a try and see if you could solve these questions without knowing or without having looked at whatever we did prior to this, the types of numbers. You could have perhaps already the prerequisite knowledge needed. So let's go. Activity number 1. They ask us here to list any 4 prime numbers less than 20. And again, the first thing that comes to our mind is, what is a prime number? Well, we would have addressed that in the previous video. So we addressed that a prime number is any number that has 2 factors, itself and 1. And here they want us to list any 4 prime numbers that is less than 20. So I could start with, let's say, 2. And I put 2 willfully because a lot of people don't know that 2 is a prime number. A lot of people think that 2 is only an even number. But 2 is a prime number. 2 only has 2 factors, itself and 1. I could also put 3. 3 is a prime number because only 2 numbers could go into 3, 1 and 3. Let's see, 4. No, 4 is not a prime number. 4 has more than 1 factor. Well, only 4 they want. So let's go higher. I'll jump to 11. 11 is a prime number because only 2 numbers could go into 11. 11 and 1. So 1 and itself, 11. And let me bring 1 closer to 17 as in 19. I mean, I like closer to 20 as in 19. They said list any 4 prime numbers less than 20. So all these are eligible. 2 only has 2 factors, 3 only has 2 factors, 11 only has 2 factors, and 19 only has 2 factors. Only 2 numbers could go into 19. 19 and 1. Only 2 numbers could go into 11. 11 and 1. And same thing goes for 3 and 2. Of course, you may not have had the same numbers that I have, but once yours classify and qualifies based on the definition that we would have addressed, then we're good to go. It doesn't have to be the exact numbers that I have. Moving on. List any 5 factors of 60. And again, we have to recall what is a factor. A factor is any number that could go into a number perfectly, or as we say, without a remainder. So let's see what could go into 60 perfectly. Well, right away, I know that 2 again is a factor. You have to stick to what you know. So 2 could go into 60, and how do I know that? I could divide this and I will get no remainder. In fact, because I could do this, I know if I divide 2 by 60, I will get 30. As a result, 30 is also a factor. I know that 5 is also a factor because I know my timetables. And because 5 is a factor, I know that 12 is a factor also. Because 5 times 12 is 60. So 5 could go into 12. 5 could go into 60 12 times. And likewise, 12 could go into 60 5 times. And of course, 1, if you're keeping it simple, 1 is also a factor of 60. 1 is a factor of every number in the world because every number could go into itself at least 1 amount of times, many times, right? So that basically answers my question there. I listed any 5 factors of 60. So I have 2, 35, 12, and 1. And if you watch the first video, remember I was I was throwing out the challenge that if there is a way for you to identify a factor besides guessing numbers, I would honestly like to know. Because this, oh, mind you, I did not guess these numbers. I know these numbers because I could work it out. but there is still a guessing element, because if I want to prove that a number is a factor, again, as I said in the last video, we can simply divide it. And when we divide and we get 0 as a remainder, then we know that the number is a factor. However, the first number we have to try to figure out, it still comes down to guessing. So I started with 2, and if I divide 2 by 60, I will get 30, and then I start guessing. But again, it seems like I'm guessing, but the other values that I'm picking out, there are values that you have to try out. But again, if I wish there to know if there is a way, of course, to identify factors without having a need to guess an initial value, or maybe even to prove by division. That would be lovely to know. Just as how I could know a odd number, an even number, I wish to know if there is a way to know factors. That would be great, right? Wouldn't it? Let's try number 3. Here they ask us to list any 4 rational numbers. And again, we have to understand what is a rational number. And in the last video, we identified that a rational number is any number that could be written as a fraction. So here I could have something like 1 over 4. That's a rational. I could have 2 over 3. That's a rational. It's as simple as understanding the definition. I could have a half. Definitely a rational. And another rational I could have is what? 5/8. Any number that could be written as a rational, as a fraction, is a rational number. So here we go. List any 4 rational numbers: a quarter, 2/3, a half, 5/8. You may not have had the same, but again, the concept is the same. And again, this, as simple as it seems, if you just did not know what is a rational number, believe me, there is nothing you could have done here. Or maybe you would have just been guessing. So that is why we need to know what types of numbers, so that a question like this is really a walkover once we understand and know the concept of that number. Good. And picture this when it comes to sets and any other thing that requires understanding the types of numbers. Algebra, complex algebra, abstract algebra. When we know the concept of the type of numbers, we shouldn't have no problem going up the ladder. Let's go. Question 4. They want us to list at least list all even numbers between 16 and 24 inclusively. I like this. And remember, in the last video we addressed the, sorry, I have to erase my numbers because it's kind of taking up on the words, but you could always look back at those videos. I honestly just wrote those numbers fractions off my head, so I don't have a copy of them. But never mind, you could always just replay the video. Right, so here they want us to list all even numbers between 16 and 24 inclusively. And because they said inclusively, we have to remember that we have to add the range if they are part of the condition. And in this case, yes, they are a part of the condition, because 16 and 24 are also actually even numbers. So my answer here should have been 16, 18, 20, moving on, 22, and 24. And that is what inclusively tells us. We have to include the 16 and the 24 because they are also part of the given range or the given domain that we are asked to list. If we don't know what this word here means, inclusively, sometimes we just put between, we just stick to the between, and we exclude the 16 and the 24. And you have to be careful. That's why we need to know these terms. And again, these are all terms that we addressed in the previous video. And again, of course, you also need to know what's an even number. Because if you don't know what is an even number, then you may not have able to even list those in between correctly. So pay attention to that. I think there is one more question here. List 4 integers less than 0. Oh, I like this. So 4 integers less than 0, any negative number that you come up with. So you could just say -1. You could even put a decimal if you want. -0.2. That will be less than 0. Let's say -100. And then you have -10. Right? So anything less than 0 is any negative number. So once a number is negative, that means that it is less than 0. And as a result, it will be an integer that is less than 0. And we have to be very careful. 0.1, let us say, for example, because I've seen this once. 0.1 is not less than 0. 0.1 is actually greater than 0. So you have to be very careful Don't worry, we're very close to doing inequalities. It's coming up. By next week, it will be coming up. So yes, if we understand our inequalities, we will know that 0 point something is actually greater than 0 and not less than 0. So you have to be very careful. I have a lot of students who believe that 0 point something is less than 0. Think about it as cents. 25 cents, for example, and that's in the context of Grenada. Everybody know what is at 25 cents. 0.25. This is 25 cents. If you have 1 cent, that is actually 0.01. That's the lowest amount of money you could have in Grenada. 1 cent. It doesn't get lower than that. And of course, this is still greater than 0. It is better than nothing. If you go to put it like that, it is better than nothing. So yes, nothing would be 0.00, and that means you have no money whatsoever. But 0.01 is greater than 0. 0.000001 is also greater than 0. It's very low, but it's greater than 0. And you have to remember that. Let's go on, true and false. And this will be the end of today's video. I think we have 4 true and false. All whole numbers are also natural numbers. And again, this comes with knowing our type of numbers. The whole numbers are the set of numbers from 0 and they go up to infinity. And the natural numbers are the numbers from 1 and they go up to infinity. So if I say all whole numbers are natural numbers, the answer to this will be false. Yes, this is not true. This is false. Why so? Because there is one whole number that is not a natural number, and that is 0. 0 is a whole number, but 0 is not a natural number. So then I cannot say that all whole numbers are natural numbers. That will be false. Yes, very close, but no. Let's go. What the second one have for us? A fraction is a rational number, and I think this one is a walk in the park. Yes, this is true. So a fraction is indeed a natural number. Sorry, a rational number too, because rational numbers are basically fractions. Good. Let's go. All irrational numbers are recurring decimals, and believe it or not, this is also true. Yes, because remember, a rational number cannot terminate, and a recurring number is a number that goes on forever. So yes, it doesn't stop. It's 0 0.5, 7, 8, 10, whatever. I keep saying 10. But yes, the numbers keep going on forever. So yes, that's the same definition for irrational. It doesn't end. It goes on and on and on. And I think we have one more. The symbol for a whole number is Z, and that is false. The symbol for a whole number is actually W, and that was all shared in the last video. So that will bring us to the end of today's video. Again, feel free to like, share, and subscribe. And look at the part 1 to this if you haven't seen it yet. So you will see, and we had a long talk on the various types of numbers. So go through it, look at them, make sense of it, and then you could come back to this video and see if you could answer these questions on your own without my input. Until then, again, you subscribe and take care.